doing notes on quadratic and absolute value inequalities. I'm going to write one variable because we're eventually going to see ones that are on an XY axis. Okay. So these notes on your page are going to be quadratic and absolute value inequalities. Okay, quadratic and absolute value inequalities. And I'm going to put one variable. So what I mean by that is, for example, okay, I'm just going to jot this down. What I'm writing, I'm going to write it in a different color. You don't need to write this down. This is just as an example. Okay, I'm going to write it in orange. Don't write it. In integrated 1, we saw something like x plus 2 is greater than 5, something like this. But we also had to solve maybe something like this. Y is greater than x plus 2. This one here is on a number line because I have one variable, just x. This one here is on an XY axis because I have an X and a Y. This one here, if I solve, is going to be X is greater than 3. And I would have had 3 here with an open circle because it's not including 3. It has to be greater than 3. And then I would have shaded this direction. X greater than 3 would have been my answer. That would have been my graph. Okay. The other situation, I would have had a graph on an XY axis. I would have gone up to 2. I would have gone up 1 over 1. I would draw a dashed line because it's not including that line. And if I want greater, I want values that are above that line. I want Y's higher than that line. So I would have shaded above that line, okay? So I just want you to understand, we will be eventually doing the second type with parabolas and absolute value graphs. But today we're doing one that's just number lines because it has just one variable, not an X and a Y, okay? Just so we understand the difference. Okay, so again, this is just an example of the difference between one variable versus two variables, okay? Okay. So I'm going to get rid of this. So what I am going to write here is something that you want to understand. That you can solve inequalities like equations. In integrated 1, they usually would make you have it equal and then try to figure out which side to shade on by plugging in values. I'm going to keep the inequality as is. The only thing is with an inequality, if you multiply or divide by a negative, you need to switch the direction of the inequality. So I'm going to jot down for us the following. Just move this. Okay. So only if you multiply or divide by a negative, okay, will you switch the direction of your inequality? So only if you are multiplying or dividing by a negative will you switch the direction of your inequality. And the reason for that is the following. I'm going to put a little example here and I'm going to take it off, but I'm just doing this to so you kind of understand why. So I'll do it in red. Again, I'm going to erase it here in a second. Do you guys agree that 100 is greater than 1? Well, what if I multiply this side by a negative and this side by a negative? Is negative 100 greater than negative 1? So negative 100 is now less than negative 1 because whatever was maybe big as a positive is now small as a negative. That's why we switch the direction of our inequality, okay? Whether we multiply or divide by a negative. I can add to both sides. If I was to take 100 greater than 1 and add 2 to both sides, this would be 102, this would be 3. That's still true. Just because I add to one side, if I'm adding to both sides, it's still, the one side's still bigger, the same as it was in the original problem. I can subtract and it's still going to be bigger. The only time it's going to change is if I multiply or divide by a negative. So sometimes I'll have people go, I'm dividing, so I have to change it. Well, if I have a 100 and a 1, I divide this by 2, this by 2, I'm going to get a 50 and I'm going to get a 1/2. I think we agree that 50 is still bigger than a 1/2. So dividing is not what makes your inequality change. It's multiplying or dividing by a negative number, okay? Multiplying or dividing by a negative number. That's the only thing that's going to change it. Okay, so let's do our actual problems. So example 1. Let's say we have x squared plus 2x minus 8 is greater than 0. And then I'm going to next to it do another equation or inequality. So in this situation, so on this problem, your book will show you setting this equal to 0, solving it, and then checking values, because you're going to get two what we call boundary points, and checking values in between and outside of those. You can do that, and I'll show you that in a second. Myself personally, I think about it as a parabola, and I'll show you what I mean. So what I want to do is I want to find out where it is 0, okay? So I'm going to factor this. And when I factor this, I'm trying to ask, okay, what multiplies to a -8 and adds to a 2? Well, that's going to be an x plus 4 and an x minus 2. And right now I'm trying to figure out what makes it 0, because that's going to be my boundary point. We always want this to be a 0 over here. So if this was not a 0 originally in this inequality, I would make this a 0 in my inequality, okay? So now what is going to make the first one a 0? Well, that's going to be a -4. The second one's going to be a +2. Those are going to be my boundary points on my number line. So I'm going to have a -4 and a 2. I need to look at my original problem to decide if I should be having closed or open circles, because it's strictly greater than, okay, no equal. I'm going to have open circles at -4 and 2. These are not solutions because they're not going to make it greater than 0. They're going to make it be 0. So I'm going to have open circles there. Open circle here. I wanted to do it in a different color. Okay. Open circle here, open circle here. Now, your book would have you take a value on this side, let's say -5, and I would substitute it into, here, I'm gonna change this like this. We're trying to think of where it is 0, but I'm just going to look at the inequality right now. So if I was to take a number, I could take -5, put it in here and see if it makes it true, or into this one. I could take a value in between here, let's say 0, and put it in here and see if it makes it true. I could take a value over here, maybe a 3. But I think about this as this is what makes it 0. These are really like x-intercepts of a parabola. This is a parabola. This is a positive parabola. So it's going to open up. So I'm going to grab a, so I think about this as a parabola. I think about this as my x-axis. This would have been one x-intercept at -4. This would have been another x-intercept at 2. So my parabola would be opening up and it would go through those points like this, right? This kind of a sketch. This is not my answer, but this is how I do these problems. So right here, and let me just make it a little more transparent. Okay. Whoops. I made it transparent. Try one more time. Okay. So what I'm trying to do here is, again, I want to know this is where it is 0, this is where it is 0. So if I'm on the outside of -4, any of the values going out here, do you see how the y's I'm getting are above the x-axis? These are greater than 0. Anything out here is greater than 0 because it's above this line. This is at 0. Anything between my -4 and 2 gives me something less than 0. That's why I'm below the x-axis. Here I'm at 0. And then again, outside of 2, I'm going to be above the x-axis. I want things greater than. So I don't want to be in between. That's going to give me values less than. I'm going to be outside because this is going to give me higher values. This is going to give me higher values. So my graph is going to look like that. The blue is my graph. Okay, the yellow is just to help me. So my answer is going to be, when you have two separate pieces of graph, you define each of them. I'm going to define this one. This one is x is less than -4. And then if I have more than one, I have to use the word or. And then this one here is x is greater than 2. This is my solution. And this is my graph. The parabola, you don't need it there. I'm using it to guide myself. So I could, like I said, take a value to in front of -4. Let's say I put in a -5. Okay, I'm just going to do this temporarily. I'm going to erase it. Okay, I could go, okay, -5 plus 4, -5 minus 2, greater than 0. Well, that's a -1 times a -7. Well, a -1 times a -7 is 7. Is 7 greater than 0? Yes, it is. If I try to value in between -4 and 2, let's say I put in 0. 0 plus 4, 0 minus 2, greater than 0. I get a 4 times -2. I get a -8. Is -8 greater than 0? No. So I don't shade in between. And then if I tried, let's say 3. 3 plus 4, 3 minus 2, to see if that's greater than 0. Well, 7 times 1 is a 7, and 7 is greater than 0. So I personally don't try these 3 locations because I understand these would make it 0. Anything out here is going to give me a value that's going to be higher than 0 because, and you see it physically here in the parabola. Anything in between here is going to give me something less than 0 because I'm down here, I'm in the negative. And anything here is going to give me a value above. So if I was to get a Desmos graph out, and type in y equal x squared minus 2x, double check it, sorry, plus 2x minus 8, sorry, plus 2x minus 8. Okay, there's my parabola, right? Well, I want to know, for example, where is it 0? So if I was to go y equals 0 and put that line in, you see it just put this blue one in here. Let me make this a little bolder. Okay, just put this blue one in here. Okay, where? At -4. Here, I'm at 2. All of these, if I follow these, all of these outputs, look at all those outputs, -2, -2.7, -3. All of these values for these x's are going to be less than 0. Where the ones outside of these, all of those y values are going to be greater than 0. All of the ones going outside of -4 are greater than 0. So you can also think about it graphically, okay? Okay. I guess I'll leave that red there as a way you can try if you want, okay? So I'm going to put another problem down here. So let's say, for example, we have, let me get my example up. We have -x squared plus 6x minus 5 is greater than or equal to 0. Okay. Now for this, I never like to have a negative in front of my x squared when I have to solve it. I like it to be a positive. So what I'm going to do, I'm just going to copy this real quick. Okay. I'm going to take that and I'm going to multiply this by a -1 or divide it by a -1, whichever way you want to think about it. Okay. So what does that do? Well, that makes this a positive x squared, a -6x, a positive 5, and this inequality is going to change direction. Why? Because I multiplied or divided, whichever way you thought about it, by a negative. That made me switch the direction of my inequality. Now, on the other side, when I times -1 with 0, I still get a 0. So I personally always change mine to open up parabolas. I personally always get rid of my negative in front. So now I'm going to factor this. So now I'm going to think about, okay, what multiplies to 5 and adds to -6? Well, that's going to be x minus 5 and x minus 1. So I'm going to get an x equal 5 and I'm going to get an x equal 1. Those are going to be my zeros. Okay, that's what makes it 0. So I'm going to drop this down a little. So I am going to have 1 and 5 on my graph. And then I need to decide if these are open or closed circles. I'm going to also pay attention to, this is what I'm looking at now, not the one original. This is what I'm focusing on right here. I want things that are less than or equal to 0. Because of the equal to, that means that these are going to be closed circles because it has to also equal it. And 5 and 1 equals 0. Make it equal 0. Then I'm just going to move this up. I am personally going to think about this again as a parabola. And this is an open up parabola. So it's going to be kind of going like this. That would be an open up parabola. So as I'm following this, everywhere here, I am above 0. Here I'm at 0. Here I'm below or less than 0. Here I'm at 0. Here I'm above. So the x's beyond 5 are going to make it greater. The x's in front of 1 are going to make it, wow, what did I do? What did I do? Can I reverse those? No, that was right. 1 and 5, right? Sorry, 1 and 5. Sorry. I thought I misread that. 1 and 5, those were right. Sorry, I thought I put them in the wrong order. So here in front of 1, these are going to be greater. Outside of 5, these are going to be greater. The ones in between 1 and 5 are going to be less than. And I want less than or equal to. So I'm going to be shading in between. I'm going to be shading in between. This is going to be my graph. 1, 5, closed dots, shade in between. The way we write that answer, we start with our left. I would start with my left side, which is 1. If you start with your left, these are going to be less than or equal to, in this case, less than or equal to, x less than or equal to 5. That's my answer. That's my graph. Now, again, if I was to put values into here, for example, if I was to put a 3, say 3 is in between 1 and 5, 3 minus 5 is a -2, 3 minus 1's a +2, -2 times a +2 is a -4, which is less than. So that's why these ones in between work. Now, the original problem was a negative. If I was to get my Desmos again, and -x² plus 6x, so y equal -x² plus 6x minus 5. You see, this would have been an upside down parabola. And in the problem, I would have wanted it to be greater than or equal to 0 in the original one as a negative. And that means, where is it above the x-axis? In between these two values, 1 and 5, just like my graph. But I made it the reverse, and so it was less than. Okay, but I get the same value. So I always change mine from a negative to an open up parabola. So the open up parabola would have gone like this, but I would have wanted where it's greater. So this would have been less than, equal, greater, 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 equal, less than. So the greater would have still been in the same location as my less than as a positive. Okay. Okay. I'm going to do one more parabola or quadratic, and then I'm going to do some absolute values. So let's say that we have the following. The next one's going to be in a slightly different format. So this is going to be the quantity x plus 3 squared is greater than 4. Now, in this form, I want this to be a 0. In this form, when we solve these, we don't make these zeros on the other side. This is like kind of in the completed square form. So I'm going to solve this as is. And I want to know what makes it 4 is kind of what I'm doing. So where would it be 4? So if I took x plus 3 squared and I had it, I'm looking to where it would be 4, I'm going to square root both sides. I'm going to end up getting an x plus 3. And when I square root the other side, I get a positive and a negative 2. Okay. So again, in this form, I would not FOIL this out or multiply it out and subtract the 4 and get 0. You can. It's more effort. This isn't a nice form. We like them in this form. I can square this side, I get an x plus 3. I'm sorry, square root this side, I get an x plus 3. I square root this, I always get a positive and a negative. Then I'm going to minus 3. So I get a negative 3 plus or minus 2. Now that's going to give me 2 boundary points. Negative 3 plus 2 is a negative 1. Negative 3 minus 2 is a negative 5. So those are going to be my boundary points. What I'm doing here, let me do it in a different color. So what I did to this was I then came and I square rooted this side and I square rooted this side. Okay. And that's how I got my x plus 3 and then my plus minus 2. Okay. And so now I'm going to put this on a graph. I have a negative 5. I have a negative 1. Okay. Looking back at the original inequality, I want it greater than 4. So right here, these two values would be at a height of 4. Okay, those would make it be 4. So I don't want it to be 4. I want it greater. That means these are going to have open circles. Open circle here, open circle here. Because you can kind of think of this as a height of 4. Like on a graph, I'm at a height of 4. So this would be 4, but I don't want that. This would be 4, but I don't want that. But still think of this as a parabola. So I'm still going to think of this as an open up parabola. Still thinking of it as an open up parabola. And let me just kind of talk it through as I'm drawing it. Outside of negative 5, negative 6, negative 7, negative 8, and so on, I'm above 4. Now I'm at 4, at negative 5. In between negative 5 and 1, I'm below 4. Once I get here, I'm at 4. And then I'm greater than 4. So I want where my values are greater than 4. So I'm not going to shade in between negative 5 and negative 1 because these ones are going to be less than that height because they're below that height. This height is now, think of it as a height of 4. Outside of negative 1, these would be above that, greater than. So I'm going to shade out here, and same with this side. So my graph is going to go out this direction and that direction. And then when I write my answer, this is going to be x is less than negative 5, or, and the other side is going to be x is greater than negative 1. Now, again, you can go and plug in values, negative 6, negative 10, whatever you want. Over here, plug in anything between negative 5 and negative 1, negative 3, let's say. You can come over here and try anything outside of negative 1, let's say 0, and plug them into this, but you're going to end up with this. So again, if I think about this real quick as a parabola, let me just put the equation in. I'm not at a height of 0 this time. I'm at a height of like 4. I'm at a height of 4 because I want it to be compared to 4. I want things bigger than 4. And then if I put in my parabola, x, what was it, plus 3 squared. And let me take all that off. Oh, I took everything off, didn't I? X plus 3 squared You see, I get a parabola. This would be like my number line, but you see how it's a height of 4? At -5, I'm at 4. At -1, I'm at 4. Anything out to the right of, let me be on this graph. Anything to the right of -1, I'm greater than 4. I'm at an 11.357. Okay, as I'm coming back down, these are still greater than 4, greater than 4. My y's are greater than 4. Okay, and then here I would be at 4. Now all of these are less than 4 until I get back to -5. And then when I go outside of -5, -6, -7, and so forth, you see all my outputs are higher than 4. Okay. Okay, so now we're going to try 2 absolute values. Let's say we have, for this example, absolute value of x minus 3 is greater than or equal to 5. So when we're doing this, we want to figure out what makes it 5. And remember, for absolute values, I get 2 answers for absolute values. The absolute value of 5 is 5, and the absolute value of -5 is 5. So this x minus 3 could have been a 5, or this x minus 3 could have been a -5. I write those 2 equations out. I want to see what makes my x minus 3 be a 5, and then what makes my x minus 3 be a -5. Okay, what's going to make this inside my absolute value a 5, or the same thing inside my absolute value a -5? So I'm going to end up getting x is equal to 8. And over here, I'm going to get x is equal to a -2. Those are going to be my boundary points on my number line. So let me draw my number line. I have a -2 and I have an 8. I look back up here and I go, okay, this is going to be equal. So these are going to be closed dots because I want it equal. So I'm going to have a dot here and a dot here, closed dots, because that's where they are 5. Now, an absolute value, again, I could take a value here, plug it in. I could take a value here, plug it in. I could take a value here, plug it in. And when I say plug it in, I'm talking about into this original inequality and see what makes it true or false. But again, I think of it as a absolute value. An absolute value is a V-shaped graph. A positive, because this is a positive in front. So here, as I'm coming outside of -2, I'm greater than 5 because I'm above that line. Once I hit that line, -2 made it 5. Anything below this is going to be less than 5. So all of these values here between -2 and 8 make this less than 5. And now I'm at greater than 5. So I wanted it greater. So I'm not going to shade in between -2 and 8 if I'm thinking of this as a height of 5, because this makes it 5, this makes it 5. All of these make it less than 5. All of these make it greater than 5. So I'm going to be shading outside, and my answer is going to be x is less than or equal to -2, or x is greater than or equal to 8. And that's my answer. And I'm going to do one more. So in Desmos, I would want this to be 5. So this right here is at a height of 5. Okay, I'll zoom out here in a second. And I would have y equal the absolute value of x minus, x minus 3. Oh, I put a c, x. Okay, let me get it bigger. So again, if I get this, okay, to go by ones here. Do you see how this is a height of 5 right here? That's kind of like where my number line is. That's my number line. Why? Because right here at -2, it made it 5. And right here at 8, it also made it 5. Anything outside of it, like 9, I'm going to be up here. 10, I'm going to be up here. These are all going to be greater than 5 when I put it in. All of these ones in between -2 and 8 are going to be less than 5. Not necessarily negative because it's not on the thing on the x-axis, but less than 5. So if I was to put a table in here of points, you see, and let me get some that go beyond this. So let me put in like a -3 and like a -4. So you see here at -4, I would have gotten a 7 out. If I plugged in -4 into that, I would have gotten a 7 out. Okay. I want it greater than 5, so that works. My -3 would have given me a 6 back. But I don't even care what the value is. I just know it would have been bigger than 5. Why? Because it's above the line. Here, I'm at 5. All of these values in between here, if I continue to my 8, 5, you see all of those are less than 5. I get a 3, I get a 4, I get a 1, I get a 2 as my outputs for each of those values. Back up at 8, I'm up at 8, and then anything here, okay, this is going to be 6, 7, 8, 9, 10. That's what I'm getting. So last one, this one, I'm going to have a little bit more going on with this one. So let's say I have, let me just grab my example. I changed it up. So let's say I have -3, -3 times the absolute value of x minus 2. Let's say +1 greater than a -21. I always want my absolute value isolated, okay? I don't want it like this. I need to get my absolute value by itself. I want this by itself. So I'm going to add 1 to both sides, and I can add 1 to both sides, and not add 1, sorry. I'm going to -1 to both sides, okay, to get rid of that +1. And I can -1 to both sides. Oh, I want this to be a 20. Sorry, I want that to be a 20. I want this to be a 20. Okay, I want that to be a 20. So I'm going to -1 to both sides, and I get a -21. Now, again, I want my absolute value by itself. So what am I going to do? I'm now going to divide by a -3, divide by a -3. But when I divide by a -3, I have to be careful. I'm going to need to switch that direction of my inequality. Why? Because I'm dividing by negatives. So I'm going to end up getting the absolute value of x minus 2, not greater than, but less than 7. Okay, again, I need to switch. It was a greater than, now it's a less than, because I divided by a -3. So now I'm going to work this out. I'm going to ask myself, okay, what makes x minus 2 equal 7? What makes x minus 2 equal a negative 7? Well, if I add 2 to both sides here, I get a 9. If I add 2 over here, I get a negative 5. These are going to be my boundary points, okay? So I'm going to put these on my number line. Negative 5, positive 9. I look at this equation here, my isolated one. That's what I'm looking at. I'm not looking back up at the original one. I want to check my inequality when I have it isolated because I've changed it. I divided by negative. It's not the same anymore. So I am going to have open circle at negative 5, open circle at 9 because it was less than, strictly less than. And again, if I think about my V-shaped graph, this is a positive. I made it a positive. This is a positive V-shaped graph. I want where it is less than 7. And it is less than 7, not outside negative 5 and 9, because then I'm above that. It's in between. And so my answer is going to be negative 5, strictly less than x, less than 9. And that's your answer.